Hello everyone, this is test number 10, looking at maths skills in chemistry, and this is the final one of the series. So hopefully you've improved your maths skills a lot during these videos. So let's have a look at the questions then. So the first question, the table below shows the boiling points of 5 compounds. Calculate the range of the boiling points. Range just means the lowest to the highest. So where's the lowest? Okay, well in this case, let's have a look. So we've got minus 88.5, the highest is 68.7. So if I take 68.7, take away minus 88.5, my total range is 157.2. So that's a straightforward 1 mark question. Okay, so question 2 then. A scientist measured the level of air pollution in a city over 5 years, and the data the scientist collected is shown in the table below. Now remember always that the one that is controlled is the independent variable and goes on the x-axis, and the one that is measured is the dependent variable and goes on the y-axis. So this one says, draw a bar chart of the data in the table on the axis below. Now first of all, if you look, the lowest number here is 93. So I don't really want to start my graph at 0 at the bottom. On the y-axis, because I'll have wasted all of this space. So what I can do is I draw this funny little squiggle which goes like that at the bottom, and that just shows that I've collapsed the graph paper, so that I know that I can then start at 90 and I've got a much better range then. So I've just got to get up to 122, so I'm going to probably go to 130. That would be a much better range on my graph. The other thing, and I made this slight mistake, I started to plot the years on the actual lines and then realised it was a bar chart. Those numbers need to go underneath where your bars are going to be drawn. Okay, so make sure you do that. When you're drawing your bars, as I've said previously, always use a ruler, and I look at 2009 and it's at 97. So I go to 2009 and I make sure my bars are equal widths apart and equal distances from the edges. So this one I've gone for 2 boxes in this way, 2 boxes in this way. I've got to go up to 97. So I use my ruler to make sure I go up to 97. I put my first point there, second point there, and then actually join it up. And make sure I use a ruler every single time. And then I plot all my bars, and that will get you your 3 marks, okay? Now, the next question says, calculate the percentage change in mean air pollution between 2009 and 2011. We've had a couple of these questions now. So basically we've got to work out the difference. We only need 2 sets of values, 2009 and 2011. That's 97, that's 122. If I take that away from that, I get 25. Divided by my original value, which is 97, times it by 100, I get the answer of 25.7, and all I've done is just rounded that up to 26%, and that's my 1 mark. This next question then is looking at, in 2013, the mean air pollution was found to contain a 3:2 ratio of carbon monoxide, sulfur dioxide and other pollutants. Calculate the level of sulfur dioxide in the air in 2013. Okay, so first of all, I need to make sure I can understand what the question's asking. So I'm just unpacking this question. I've just put the ratio over here, 3:2. Carbon monoxide, I've just put a C. Technically it's CO. Sulfur dioxide is CO2, but I've just put that just to remind me, and then I've just put O for other pollutants. I've just put it underneath each part of the ratio so I know what I'm looking at. I want to look at the level of sulfur dioxide. I want this one here. So I want to know what 2 parts out of my total 7 would be. Okay, now we're looking at the year 2013. So 2013 was 102. If I divide that by 7, I will work out what 1 part is, which is 14.57. But I need to know 2 parts from my ratio. So 14.57 times 2 equals 29.14. And I've just rounded it to 29. Question 5. A student carried out a reaction and obtained 54 grams of the desired product. This was 92.6% of the original mass of the reactants. Calculate the mass of the reactants. Now, before I even tackle this question, I'm going to sort of make a little bit of an estimate. If 54 grams is representing 92%, then my answer is probably going to be about 60 grams maximum. Okay, so sort of straight away I'm thinking I've got a 60 gram estimate because that is already 92%. So all I need to do is 54 divided by 0.926, because that was the percentage and I've converted it, equals 58.315. So I've rounded it up and the answer is 58. And if I check back to my original estimate, I estimated about 60. So actually that's about right. So I know that I'm in the right sort of area and I've got the right answer. If you did 54 divided by 92.6, you would not have got 58. So you would have known you'd have had to have converted your percentage into a decimal place first. So that's why the estimate works. Lastly, this question, the diagram below represents a nanoparticle. Its dimensions are given in metres. Calculate the surface area of this nanoparticle and give your answer in standard form. Again, 2 marks, one for working it out, one for converting to standard form. So I just want the surface area. So 5.0 times 10 to the minus 9 times the height, and that's what I've got here. But I want the surface. So I work out one surface, so that times that, and then I multiply it by 6 because I've got 6 surfaces. And I get an answer of 1.5 times 10 to the minus 16. If they wanted me to work out the volume, then I would have measured and multiplied the width and the height and the depth. That's the volume. Just to work out the surface area, I work out one and multiply it by the number of surfaces. And that's where I get that answer. I hope these maths skills lessons have helped you to improve your maths in chemistry. And thank you very much for watching.